Hey, how's it going? So for this module, we'll be looking at the volume and surface area of three-dimensional objects. We'll be looking at pyramids, cones, and spheres. So once again, we got the formula sheet over here that you'll have. So remember, you don't have to memorize anything that's on the formula sheet. It's going to be given to you. You got to be able to utilize it. All right. So now, volume of a right cone. So if I want to find the volume of a right cone, formula is given to you. So if I'm given a figure like this, you know the diameter is 4. So you can simply just divide it by 2, which is 2, and plug it in and evaluate. This is a problem that you should be able to do by hand to get to 8 pi though. So 2 squared is 4. 4 times 6 is 24. Remember, multiply by the numerator, divide by the denominator. 24 times 1 is 24. 24 divided by 3 is 8. All right, so you have 8 pi, and if they want the decimal, you take it to the third decimal place. Now if I get a problem like this where I give you the radius, well, they give you the radius already, you just plug and chug. And you get 21 pi, which is also 65.973. So now, what if you get a problem like this? All right, you're like, okay, I got the radius, it's half of 6, which is 3. And I got the height, which is set. No, it's not. Height is not 7. This is your slant height. All right, the height is this right here. So if you're looking for the height, you're going to utilize the Pythagorean theorem in order to find said height. So if we know that the radius is half of the diameter, which is 3, so then we have 3 here. The hypotenuse, which is going to be the slant height here, which is 7, and then that's going to help us find the height here. So then now we'll utilize that Pythagorean theorem. So it'll be 3 squared plus a squared equals 7 squared. And then you will solve. So we get 9 plus a squared equals 49. Subtract 9 and you get square root of 40. Now that can be simplified. So that can be simplified down to 2 square root of 10, or if they just want to give you a decimal, it'll be 6.325. Question might come up of, how did you go from square root of 40 to 2 square roots of 10? You got to look at what are the perfect squares that can evenly go into 40. 4 is a perfect square. Square root of 4 is 2, so you can take it out. 10, there's no perfect square that can go into 10 evenly, so we just leave that underneath it. All right, and then you get 6.325 if you take it to a decimal. All right, so then now that you have your height, you can plug your height in. Now, I plugged in 2 square root of 10 because I want to find the exact value. All right. Now, and you will get 2 square root of 10 pi because 2 square root of 10 times 3 is 6 square root of 10. 6 times 1 is 6. Divided by 3 is 2. 2 square root of 10 pi, which is equivalent to your decimal, which is 19.869. If this is a non-calculator portion, they're going to be looking for the square root of 40 pi or the 2 square roots of 10 pi. So you need to be comfortable going either direction. All right. But if they give you a calculator, you can go ahead and write 19.869. Make sure you show all your steps on your notes though. As a side note, in regards to like how problems will probably be asked to you, you're probably going to have to go find something in order to just evaluate it. They're probably not going to do as much plug and chug because that's what you've seen when you was in geometry. All right. Something to think about as we go through the rest of these problems. Now we're going to look at the area of the curved surface of a cone. And once again, the formula will be given to you. The way you read this is the area is going to equal pi times the radius times the slant height. So for this problem, the slant height is already given to you, which is 7. So then you just plug it in. We know the radius is 3 and the slant height is 7, and you should be able to get to your answer. Now, if I give you a problem like this, the slant height is no longer given. The radius is given because you can find it from the diameter. It's going to be half of that, which is 3. But the height is 9. You're looking for the slant height. So once again, now you got to use the Pythagorean theorem. So this will be 3, this will be 9, and then you're looking for here, which means now you're looking for the hypotenuse. So it should look like this. 9 squared plus 3 squared is equal to L squared, which is the slant height, which I'm going to need for the area of the curved surface of this cone. Once you solve, you work your way down, you get square root of 90. And think about the perfect square that can evenly go into 90. This happens to be 9 here. So the square root of 9 is 3, so that'll be 3 square root of 10. That's the slant height. And if you take it to a decimal by typing it into your calculator, you'll get 9.487. So I'm going to leave it as the 3 square root of 10. But if this is something that you're struggling with getting to, you can leave it as square root of 90 here. So at least you'll get your points for the process, and you might get a point taken off at the end because you didn't simplify. But just write it as square root of 90 and just keep working through your problem still. All right. I'm going to take it here, and then I'll take 3 times 3 square root of 10, which is 9 square root of 10. So my answer is 9 square root of 10 pi. But let's say you couldn't simplify it, or you struggled with this portion of it, you would have pi times 3 times square root of 90. So then you would have 3 square root of 90 pi, which is the correct answer. It's just not simplified. So you might get a point taken off, but you will get majority of the points by at least showing that. All right. So don't give up just because you might struggle with a portion of it. And that decimal would be 89.411. So now volume of a right pyramid. So 1/3 times the area of the base times the height. So the area of the base, this is a triangle at the area of the base. So 1/2 times 6 times 8. And that would give you 24. And then you'll take 24 times 1, which is 24, divide by 3, which is 8. 8 times 12 is 96. All right, so that's the area of the volume of the right pyramid. So then now here, do the same process. Now instead of taking 1/2 times 6 times 8, you're taking 11 times 7 because it's a rectangle as your base. And you get 77. At this point, you could take 77 times 15 and then divide it by 3 technically, because that's just a 1 at the top. Or you could take either one of these numbers and divide it by 3. 15 and 3 go in there evenly. So I could take 15 divided by 3 and get 5. And take 77 times 5 and get 385. That's the volume here. All right. Or I could just give you the area of the base and I'm telling you the height. So you don't have to even evaluate that. You would simply just put 27 times 5 times 1/3. All right. And can 3 go into either one of these evenly like it did 15? Yeah, 27. So that gives you 9. So then 9 times 5, which is 45. All right. But you could have technically said 27 times 5 and then divided that by 3. And you still would have gotten 45. So now if we get a figure like this, so 1/3 times the area of the base, which is going to be 5 times 5, which is going to be 25. So then now we're looking for the height. The height is not 3. That's the slant height that is 3. All right. So then now we got to use the Pythagorean theorem again. So this is going to be our hypotenuse. We're looking for the height. All right. So that's going to be our x or our unknown, our h. Now, if I drop a line from this tip to the middle here, think about where we're at. If I had to draw it back to the edge, that's only going to be half of this distance. So that's going to be 2.5. So then that means it's going to be 2.5 squared plus the height squared is going to equal 3 squared, which gives us 6.25 plus h squared equals 9. And then we solve. Now, if you have a decimal as one of your initial points as you're evaluating, you just keep it at the decimal. All right, this will probably be a calculator question if they give you numbers looking like this. All right, so our height is 1.658. So we go ahead and plug that in and evaluate, and we'll get 13.819. Now, what about the volume of a sphere? So the volume of a sphere is the formula that's given here. So then now, of course, if I give you the sphere and I give you the radius, just plug and chug. That 3 to the third, that just means 3 times 3, which is 9, times 3 again, which is 27. And then now, once again, you multiply by the numerator, divide by the denominator. But you can go the other direction. 27 divided by 3 is 9. 9 times 4 is 36, so 36 pi. All right? Or 113.097 at the decimal. And before we move to the next problem, don't forget a hemisphere is half of the sphere. So if they ask you for the hemisphere, the volume of the hemisphere, do the whole problem and just divide it by 2 at the end. You don't divide it by 2 too early and throw yourself off. Just wait to the end and divide it by 2. So the surface area of a sphere, if they ask you for the hemisphere, do the same thing. Find the surface area of the whole thing and then divide it by 2 at the end. So that's 4 pi r squared. So if I give you the diameter, just divide it by 2 to get the radius and plug and chug. And you get your answers here. Now, these are questions that's more likely to see on your assessment. What if I tell you the surface area is 100 pi? And I want to know the volume. So we know the volume is 4 over 3 times pi times r to the third. 4 over 3 is just a number. Pi is just a number. Now r to the third. So all we need is the radius. We don't know the radius yet, but we have some information. So literally write down what you know. The only thing that we know in this problem is that the surface area is 100 pi. So we're going to write 100 pi and we're going to set it equal to the surface area because we know that that's true. You only got one variable there, which is the r. So we got to solve for r in order to find what the radius is. And then once we get that, we plug it into the volume formula, and that's our answer. So we're looking for r, so we got to isolate that. We only got one term, so we don't have to move another term away. Now we got to divide or multiply. 4 times pi times r squared. So we'll divide by 4 pi on both sides, and we'll get 25 equals r squared. Take the square root to get rid of the squared, and you get 5 equals r. So that's our radius. Now just plug it into the volume formula. And once you get that, you should get 500 pi over 3, or 523.599. These questions are more likely to be asked from you because it requires a higher level of thinking. All right. So this is kind of what you're going to be expected as we progress throughout this specific module. Now let's go. We're going to look at several problems that are similar to that one. The volume of a cone is 50. Express r in terms of h. Express r means you're looking for r. It should be r equals. And in terms of h, that means it should be r equals, and the only variable on that other side should be h. All right, so r equals, and the only variables on the other side should be h, because it says in terms of h. So then now, volume of a cone, what do we know? Volume of a cone is 50. So put 50 equals the volume of the cone, 1/3 pi r squared h. Express r, you're solving for it. All right, so then now, this is just one term. So then now we're going to be multiplying or dividing to move everything else away. In order to get rid of a denominator, multiply by it. So multiply 3 to both sides to get that 150. Now that's pi times r squared times h. Divide by pi h, and you're left with r squared. We're not done here because we need r by itself, not r squared by itself. So to get rid of that squared, we take the square root. And once we do that, now we have r in terms of h. The only variable over here is h, and we have r by itself. Now we have like a double problem, I would say. All right. So let's start the left side. Given the surface area of a cylinder, formula below, which is give you here, is 100 pi, express h in terms of r. So here we're solving for h, and the only variable on the other side should be r. So what do we know? The surface area is 100 pi. So take 100 pi and set it equal to the surface area. You're solving for h. So first thing you need to do is figure out where you see h. You only see h in one place. If we only see it in one place, isolate that term and solve for h. Multiply or divide whatever is left next to that variable. So in this problem, we're going to isolate 2 pi r h because that's the only place you see h. So we'll subtract 2 pi r squared, and we get this. Now the next step would be to divide out 2 pi r so you can isolate h. Now what I want to show you now is, what if it was written differently? So if you look at this example, you don't have to write this example, but if you look at this example, I just added an h in this place over here. So let's say I look at it and I say, wait, I don't just have one h here and I got to isolate that term and divide or multiply to isolate that. What if I have h in 2 different places? If you have the variable that you're looking for in 2 different places, you keep all the terms with that variable together. Any other terms you move away, but if it has the variable that you're trying to solve for, group those together. As you can see here, I will leave both of them over here because they both have an h. Once you do that, factor out the variable that you're looking for. So when I divide out h here, I'm left with 2 pi r. When I divide out h here, I'm left with 2 pi r squared. So now you only have that one h. And then you can divide by whatever you had in the parentheses over here now. Now you got h by itself. So if it's just one term that has the variable, isolate that term, divide or multiply to get that term by itself. If you have that variable in more than one term, keep those together and move everything else. Then factor out that variable that you're trying to solve for, and then just divide out what's in that parentheses. And then you should have your variable by itself. So just be aware that this is a very popular way of solving for problems too. So don't just assume that you see the h, move everything else. If you see it there in 2 different terms, you got to keep those together and do this extra step. All right, let's back to this problem though. So then now we'll divide by 2 pi r because we want to get h by itself. Now, from here, we want to say, what can go into both of these terms that's in the denominator? 2 can go into 100 50 times. 2 can go into 2 one time. So the 2 can actually be simplified to 50 pi minus pi r squared, because the 2 divided by 2 is 1. You don't have to write that. Now pi. Pi is in the first term and it's in the second term. So technically I could divide out by 2 pi, and I would be left with 50 minus r squared. Now look at the r. There's an r here, so that can divide out evenly. There's no r here. If it cannot be divided out of both terms, you cannot do anything with it. Leave it alone. So the r is going to stay in the denominator. When you divide the 2 pi out, you'll be left with the 50 minus the r squared all over r, as you can see here. Now the final portion. Hence express the volume in terms of r. So you want to express this volume, which is this formula here, but in terms of r. But the pi r squared is fine. But if it's in terms of r, that should be the only variable over there. You have an h over here. So you got to rewrite this h in terms of r, but luckily we already have done it. So we replace h with the 50 minus r squared over r. So if you look now we have the volume in terms of r. We only have r over here now in our volume formula. So then now we would simplify by really just multiplying this to our numerator. So 50 pi r squared minus pi r to the 4th. And then notice that, wait, you have the denominator of r. R can go into both terms now. So now you're left with just 1 r here and 3 r's here, and this will be your simplified expression. All right. Now it's time to practice. Questions, concerns? Feel free to let me know.